this lesson we're going to be looking at how to find the equation of a parallel line. So for the last couple of lessons we've been looking at drawing graphs of perhaps a graph with an equation of say y equals 3x plus 1. Well, we've learned so far that this little plus 1 represents the y-intercept, so that's the point where it crosses the y-axis. The 3 is the gradient, so that tells us the steepness of the graph. Well, what you could get asked to do without doing any form of graphing is to find lines that are parallel to this. For two lines to be parallel, or two equations to be parallel, all they need to have is the same gradient. So if it just asked me in an exam to find an equation that was parallel to this, all I would need to do is ensure that my next graph had the exact same gradient, so the same number in front of the x, and just any other number at the end. So again, it could be y equals 3x minus 9, or y equals 3x minus 149,000. The number at the end does not matter as long as it is not 1, because that would not be a parallel line, that would just be the same line. So this works in any scenario. So if I was to give you a different equation, so it could be maybe a fraction, and if the question just said find a line that is parallel to this, all I would need to do is ensure that the gradient, the bit in front of the x, is exactly the same, and just change it in terms of the y-intercept, so the point where it crosses the y-axis would just need to be different. The second part of this topic becomes a little bit trickier. So what it could ask you to do is to find a line parallel to a given equation. So in this example I'm going to use y equals 2x minus 3, but then give you an added element that we needed to also do, and say that we want a line that passes through a particular coordinate. So for this example, I'm going to say it's going to pass through the coordinate 1, 9. Now, in order to do this, we first off need to find a line that is parallel, therefore has the exact same gradient. So the first thing I'm going to write down is y equals 2x. That will get me my first mark in an exam because I've got a line that is parallel. In order to find the specific line that passes through the coordinate 1, 9, I need to know what number to put on the end to make this work. At the moment I don't know what that is, so what I'm going to put is plus c at the end of my equation, where c is going to be a number that I'm going to find in a moment hopefully. Now, in order to find the specific one that passes through 1, 9, what I now need to do is substitute in some values into this equation, and the ones I'm going to use are actually this coordinate. You've learned ever since year 7 that the first number in the bracket is the x coordinate and the second number is the y coordinate, hence why it's always been along the corridor up the stairs, x coordinate, y coordinate. So if I do this and replace the letter x with 1, y with 9, all I'm going to do, so y I replace with the number 9, as it says over here, equals, well, 2x, so that becomes 2 times 1, just replacing it with the number in this coordinate, plus c. So this gives me that 9 is equal to, well, 2 times 1 is 2, plus c. So from this, just a little bit of solving, I get that c must be equal to 7, because I've just taken 2 away from both sides. So now that we know c is 7, what I can do is go back to the starting point of this question, and I'm just going to rewrite my equation. Now that I know that it's going to have to be y equals 2x, that makes it parallel, and c is 7, so plus 7. So this would be an example of a line that's parallel passing through a particular point. Let's just see another example of this. because sometimes the numbers can get a little bit trickier. So for this one, let's try y equals 3x plus 2. I want a parallel line to this, but this time I want it to pass through the coordinate 5, 2. So the first thing I need to do is write down a line that is parallel to y equals 3x plus 2. So at that point, I simply need to write down y equals 3x. Because the number in front of the x is the same, that makes it parallel. I don't know what number I need at the end yet, so I just put plus c. In order to find out what value I need for this, I substitute in the values that we've got here. So if x is 5 and y is 2, I write down 2 equals, so just replacing the y with 2, and replacing x with 5, we get this. So here we've got 2 is equal to 3 times 5, so 15, plus c. If we use our normal method for solving, in other words try and get c on its own, we would have to take 15 away from both sides to give me that c is equal to 2 take away 15, so minus 13. So we get that c is minus 13. So putting this into our equation just here, we get that y is equal to 3x. I don't need to put plus c anymore because I now know that c is minus 13. So I replace all of it, the plus c as well, with just minus 13. So this line is both parallel and passes through the coordinate 5, 2. Let's just see one final example with a little bit more complexity. So for this one, if we say that we want a line that is parallel to 2y equals 5x plus 4, so we want one that is parallel to this. We want it passing through, let's say the coordinate 6, 4. Now this is the information that you'll be given in the exam. So when I'm writing this down to start off with, this is me making up the exam question that you would be given to do. So the first thing I need to do is actually look at this equation. Now this is not in the normal form y equals. So the first thing we actually have to do is try and get y on its own. So we're going to basically make y the subject of this equation. In order to do that, I would have to divide everything by 2 to make it just y on this side, but also remember we'd have to divide this side by 2 as well. So here we would get y equals 5 divided by 2 will give me 2.5x. 4 divided by 2 would give me plus 2. So this is just rewriting the original equation. I now need to write down one that is parallel to this line. So this would have to be y equals 2.5x plus c, because we don't know what point we need for it to be parallel, and passing through 6, 4. So then we just substitute in the coordinate 6, 4 into this. So the y coordinate is 4. So let's change the y to a 4. X is now 6 because we're replacing it with this particular coordinate. So we get 2.5 times 6 plus c. So at that point we get 4 is equal to, well, 2.5 times 6 gives us 15. You could use a calculator if you wanted at that point, plus c. So to get c on its own, I'd take 15 away from both sides of this. So that gives me that C is equal to 4 take away 15, so minus 11. If you don't like it written this way round, you can turn it round and say that C equals minus 11. And then at that point, I would just need to rewrite this little equation here, but with the correct value for C. So we get that Y is equal to 2.5x, replacing the plus C with minus 11, so minus 11. And that would be the line that's parallel to this, passing through this coordinate.